Hello again, students. Here we go. Let's talk about 3-6. So we're talking about compound inequalities. Well, when you graph inequalities and it ever says the word and, so it gives you two inequalities and says the word and, that means you only graph where they overlap, okay, where they both cross or where they both graph on the line. When it says or, then you simply just graph both of them on the line. So again, when it says and, you basically have to meet both requirements of the inequality, so that's why we only graph the overlap, because that's where it works for both graphs. But when it says or, we just basically put them both on the graph. Okay, here we go. Here's the guided question from page 201 after looking at problem number 1 from the book. It says graph x is greater than or equal to -4 and x is less than 6. Well, here's the thing, folks. You can actually flip this one, okay? If it lines up where x is actually between a big number and a small number, you can rewrite it like this. So this is a compound inequality that's written all as one inequality. So x is in the middle, it's less than 6, but it's also greater than -4. So you kind of stay on your toes about that. If a variable is greater than a small number and it's less than a big number, you can put it together all in one graph. So all these are actually really easy to make. So now we have two boundary points. We've got 6 and -4. Solid dot on -4 because of that symbol, open dot on 6 because of that symbol. There you go. Again, this is where they overlap. Here's the individual graphs. Okay, where do they overlap? They overlap from here to here, and they basically inherit the original dots, the individual dots, excuse me. Part B is an or, okay? So we basically just graph them together, okay? X is less than or equal to 2.5, solid dot 2.5 going left. Or x is greater than 6, open circle on 6 going to the right. Now since it's an or, okay, you can graph both of them on one graph. Now if this was an and, okay, if this happened to be an and, where do they overlap? Well, they don't at all. So if you were ever to graph one that said less than 2.5 and greater than 6, there's no such thing. There's no such thing as a number that's less than 2.5 and greater than 6. Doesn't happen, okay? So if the graphs don't touch, they have no overlap. So if you ever have one of those, you would just say no solution. 1C, what's the difference when it says between A and B and then it says between A and B inclusive? Well, if it says between A and B, you do not include A and B. It's between A and B. But if it's between A and B and then it says inclusive, then you, well, include A and B. So don't think too hard about that one. Got it, question number 2 from page 201. I want you to solve and graph. Now, these things are kind of crazy. So when they have a compound inequality with all this stuff in the middle, okay, so it looks kind of like one of these, okay, it's actually not much different than solving a 1 or 2 step equation or a 1 or 2 step inequality. You just kind of extend your idea, okay? Whatever you do to the middle now, because you want to get the variable all by itself in the middle, it's between two boundary points. All right, whatever you do to the middle, you do to the right and the left. So basically, you do the same thing to all three pieces. You got a middle, you got a right, you got a left. Do everything. So do the same thing to everything. So how do you get rid of a -4? +4, +4, +4. Okay, rewrite everything. How do you get rid of a ×3? Divide by 3. So divide by 3, divide by 3. Boom. There you go. Solve. Y is all by itself. It's less than 6. It's bigger than 2/3. Open circle, connect the dots. Okay. So again, whatever you do to the middle, you have to do to the outside. Whatever you do to the middle, you do to the outside. Do to the middle, do to the outside. Moving on. The guided question to number 3. Okay, when can you use this with some complex multi-step compound inequality questions? I'll try to throw as many big words in there as I could. Well, here's a problem where you have scored 78, 78, 79, and you want to take a 4th test and you want to score a B. So what is a B? Well, a B is between, including 80 to 89%. Okay, that's what a B is. So it's inclusive, inclusive. So from 80 to 89 is where you want to score. You will score in between there. So basically it's, here's your score, here's your score, here's your score, here's your 4th score, and then your average after your 4th score, that's why I'm dividing by 4, needs to be between, and including 80 to 89. So it's most of the problem is in the setup here. So watch what I do here. I already took everything ×4, okay? It was kind of hard to write it in all the individual spots, so I just take everything ×4. So I'm taking the right side ×4, I'm taking this ×4, because I want that 4 to cancel, and I'm going to take this ×4. So as you can see, I took everything ×4, ×4, the 4's cancel. Where does this number come from? I added those 3 numbers up. So I kind of did 2 moves in one. I added those, simplified it, and then I also canceled out the 4. Okay, so times 4. So now I got 235 points that I've already scored, plus my 4th test, which I don't know what it is yet. We'll see what it could be. So then I subtract 235 from both sides. When I do that, I get 85 for my minimum, and I get 121 for my maximum. Now, most tests, I think the best you can do is 100 points. So in real life, so this is your mathematical answer, but your real answer would be, well, I got to score at least an 85 to a perfect. Okay, so that's why I say at least an 85. So if you want an average of B, you got to get at least an 85 on that 4th test. Okay. Last thing we'll talk about is this really nerdy stuff called interval notation. It's kind of a way to make a nice little list of inequalities. All you really do is if you have open ends, you use these brackets right here. If you have closed ends, you use the square brackets, the solid brackets. So technically these are parentheses and these are brackets, but parentheses mess with my Lisp sometimes. Now if your line continues all the way to the right, then you use the infinity symbol. So the graph's going to point to the right. If the graph points all the way to the left, you use the negative infinity symbol. What are you talking about? Well, there's plenty of examples in the book, but here's a couple that I think I took out of the book. These actually go into your notes, I believe. So here's x is greater than or equal to 2. Okay, solid dot going to the right. How would you write this in interval notation? Well, it's kind of its own little language here. It's kind of code. Okay, they're all related though. Okay, so what's going on here is we start at 2 and we go to the right with a solid dot. So you use a square bracket with a 2, and then you're going to go to positive infinity, because that's what this line is going, folks. This line is going to positive infinity forever and ever and ever, okay? So solid dot, square bracket, solid dot, square bracket, on 2, going to infinity, and then you just close it. Anytime you have an infinity symbol, you close it with a parenthesis, okay? What about x is less than 2? Open dot going to the left, all right? Well, it's going to go to negative infinity forever and ever this way, and then it starts at 2 on the right with a soft, okay, parenthesis, or a soft bracket, I guess you could say. So open dot, soft bracket, solid dot, hard bracket. Try to make that connection, folks, all right? Now, what about, it's best written in these ones right here. These are the ones that I like to look at the most. What about this compound inequality where x is greater than 1, but it's less than or equal to 5? Well, open dot, solid dot, connect the dots. Now look over here. Open dot on 1, soft bracket on 1, solid dot on 5, hard bracket on 5. There you go. There's the connection right there. So this is the interval notation of this graph, and this graph is graphing this compound inequality. So eventually, you could, if you wanted to, you could skip and go all the way from the inequality to the interval notation. And then these ones, I really don't like these ones because what's the point of writing 2 of them when this is just so efficient here? So we have something that's less than -3, or it's greater than or equal to 4. So here's the going to negative infinity, point all the way to the left, starts -3, open circle, soft bracket, solid dot on 4, hard bracket on 4, and then it goes to positive infinity. Okay, I know that was a lot of stuff, but 3/6 is, well, it's kind of a big deal. So replay this video, slow it down, push pause, do what you got to do. Otherwise, that's all I got for you. All right, bye-bye.